Let's practice our exponent properties or rules involving products or when we are multiplying. For number 1, we have x to the 5th power times x to the 2nd power. So when we're multiplying and they have the same base, we can go ahead and combine them. So instead of writing these separately, we can go ahead and write x, which is the same base that they had here, and we can add their exponents. So we can add 5 plus 2. Okay, now 5 plus 2 is 7, so we can write our final expression here as x raised to the 7th power, since it's x is the base and 5 plus 2 is 7. So we would have 7 x's multiplied together. For number 2, we have y to the 5th power times y to the 8th power. So that's 5 y's multiplied together times another 8 y's that are multiplied together. So if we go ahead and write this, we can write it using just one y, okay, since they have the same base. And we can go ahead and add these exponents. So we can write 5 plus 8. Now 5 plus 8 is equal to 13, so our final expression here is going to be y to the 13th power, and notice they have the same base, so we can just write it using one base instead of two. For number 3, we have x to the negative 6th power times x to the positive 10th power. They have the same base of x and x here, so we're going to follow the same rules even though we have a negative exponent. That's okay. So our base is x here, and we're going to take this negative 6, and we're going to add 10. Now what's negative 6 plus 10? That's going to be the same thing as 10 minus 6, so we can rewrite this as x to the 4th power. That's our simplified expression. Notice how number 1, we added those exponents of 5 and 2 together to get the 7. We added the 5 and 8 together, and that got us the 13. And then the negative 6 and 10 together, if we added those, we got positive 4. For number 4, we have y to the 5th power times y to the negative 2nd power. Notice they have the same base again. So we have a y and a y here, so we can go ahead and combine this and write one base. Of course, that same base is going to be y here. And let's go ahead and add their exponents together. So we have 5 plus this negative 2. Now what's 5 plus negative 2? Well, that's the same thing as 5 minus 2, so we can rewrite this as y to the positive 3rd power. So when multiplying these powers together, we can go ahead and add these exponents if they have the same base of y here, and we're going to get y to the 3rd power. Here's number 5. For number 5, we have x to the 4th power times x to the negative 6th power times x to the 9th power. So even though we have 3 of these bases, they're all the same, so we can go ahead and combine these. So we're just going to have x as our base here. And let's go ahead and add these exponents. So we're going to have 4 plus this negative 6 plus this positive 9. Now looking at these exponents together here, well, 4 plus negative 6, that's going to be negative 2, and negative 2 plus 9 is going to be positive 7. So combining all this, we're going to have this x as our base, and our exponent here is going to be positive 7. Taking this 4 and the negative 6 and the positive 9, if we add all 3 of those numbers together, we get positive 7. For number 6, we have y to the negative 5th power times y to the 3rd power times y to the positive 14th power. Now we all have the same base of y, y, and y, so we can go ahead and write that this is going to be y as the base, and we can go ahead and add their exponents of negative 5 plus 3 plus 14. Let's go ahead and add each of these exponents together here. So we have y, of course, as our base. Now negative 5 plus 3 is going to be negative 2, and then negative 2 plus 14 is going to be positive 12. So we're going to have y to the positive 12th power. Since the bases were the same, we took this negative 5, 3, and 14, we added them together, and we got positive 12 for the exponent. For number 7, we have x to the 4th power times y to the 8th power times x to the 3rd power times y to the 7th power. So everything's technically being multiplied together here. Now we can't multiply everything together here, but we can multiply things with the same bases. So this x to the 4th power and this x to the 3rd power, those can be multiplied together. So we're going to write x using just one base this time. We can add their exponents of 4 plus 3. And then we can multiply this y to the 8th power by y to the 7th power since they have the same base. So we're going to multiply those. That's going to be y. We'll use that same base of y. And then their exponents of 8 plus 7, let's go ahead and put those together as their power. Now simplifying this just a little bit here, we're going to have an x. And this x over here is going to be raised to the 4 plus 3 power, which is 4 plus 3, that's going to be 7. Now in terms of the y's, we're going to have this y as our base here. And if we go ahead and add this 8 plus 7 is 15. So it's going to be y to the 15th power. So starting with the x's, we had this 4th power and 3rd power. We added 4 plus 3 to get our 7 over here. And then we took this 8 and this 7, we added 8 plus 7, and we got 15 for that power over here, or that exponent. For number 8, we have x to the negative 5th power times y to the negative 3rd power times x to the 8th power times y to the negative 9th power. So let's go ahead and multiply the pieces that have the same basis. We're going to go ahead and multiply this x to the negative 5th power times x to the positive 8th power. So if we go ahead and do that, we can have this one base of x here. And when we do that, we're going to go ahead and add their exponents. We have a negative 5 plus 8. And then for our y's, we have y to the negative 3rd power times y to the negative 9th power. So we're going to multiply that, and that's going to be y as our base. So that's going to be our y. And let's go ahead and add those exponents of negative 3 plus negative 9. Now, simplifying the x first here, we have this x as our base. Let's go ahead and then add this negative 5 plus 8. That's going to be positive 3. Let's go ahead and write that over here. And then dealing with the y's now, let's go ahead and write our y as our base here. And then if we go ahead and add negative 3 plus negative 9, that's going to be more negative. That's going to be y to the negative 12th power. So starting with the x's, this negative 5 and 8 combined, we added them together, and that got us this positive 3. And then for the y's, we had this negative 3 and the negative 9. We went ahead and added them together, and we got negative 12. Here's number 9. For number 9, we have some coefficients that are now involved here, or numbers that are being multiplied by a variable. So we have 3x to the 5th power times 2x to the 7th power. So what we're actually going to do here is start with the coefficient. So this 3 in front is going to multiply by this 2. So that 3 times 2 is going to get us a 6. So there's going to be a 6 in our answer here. Moving on to the variables, we have this x to the 5th power times x to the 7th power. So we're going to multiply that by x, and that's going to be our base here. Let's go ahead and add the exponents of 5 plus 7, since they both had the same base. So of course we have the 6 in the beginning. We already dealt with that. That was from 3 times 2. And then we have this base of x. And that x is going to be raised to the 5 plus 7 power. Now 5 plus 7, that's going to equal 12. So our simplified expression here is going to be 6x to the 12th power. For number 10, we have 7y to the 4th power times 4y to the 5th power. Let's go ahead and follow the same pattern as in the last one and multiply the coefficients together first. This 7 times 4 in front, that's going to be 28. So let's go ahead and write that out in front as well. And then what are we going to do with these y's? This y to the 4th power can multiply by the y to the 5th power, since they have the same base of y. So let's go ahead and write that. And when they have the same base, let's add their exponents. We have 4 plus 5. So we're going to leave that 28 alone. That's going to be the coefficient for our most simplified expression. And then we're going to go ahead and write this y that had that common base here, and then adding 4 plus 5, or these exponents, 4 plus 5, that's going to be 9. So we have 28y to the 9th power. So in number 9, when we multiplied those coefficients together, we got 6. And then when we added this 5 plus 7 together, we got this exponent of 12. And in number 10, that 7 times 4 got us our coefficient of 28 for our expression. And then because these y's had the same bases, we could add 4 plus 5 together to get our exponent of 9. So we had y to the 9th power. In number 11, we have 3x to the 5th power times y times 8x to the 3rd power times y to the 4th power. Start by multiplying the coefficients together. So we have 3 times 8. 3 times 8 is going to be 24. So let's start there. Moving on to the x's, we have x to the 5th power times x to the 3rd power. So let's go ahead and write our x here. And that's going to be the same base. So we can go ahead and add their exponents of 5 plus 3. And then moving on to the y's, we technically have a y to the 1st power here, right? And that's being multiplied by a y to the 4th power. So they're going to have the same base of y when we combine those. And then what are we adding? We're really adding a 1 plus 4 for their exponents. All right, so simplifying this and putting it all together, we're going to have 24 for our coefficient. That's going to stay in front here. And then for x, let's see, we have x as our base here. And let's go ahead and add this 5 plus 3. 5 plus 3, that's going to be to the 8th power. And then for our y, we have this base of y, and that's being added this 1 plus 4 together. 1 plus 4 is going to be 5, so it's going to be y to the 5th power. So we got this 24 from multiplying this 3 times 8 together, then multiplying this x to the 5th times x to the 3rd. If we go ahead and take that little 5 and little 3, we add those together, we get a little 8 here. And then for our y to the 1 times y to the 4th, we can go ahead and add that little 1 and little 4 together. 1 plus 4, that gets us our exponent of 5. For number 12, we have 4x to the negative 5th power times y to the 3rd power times 5x to the negative 2nd power times y to the negative 7th power. Let's start with the coefficients here. We have 4 times 5. 4 times 5 is going to be 20, so let's put that 20 out in front. Then this x to the negative 5th power times x to the negative 2nd power. Let's put that x here. They have the same base. We can go ahead and add their exponents together. So it's going to be negative 5 plus negative 2. And then moving on to the y's, we have y to the third power times y to the negative seventh power. So we're going to put a y here, and let's go ahead and raise that to those powers added together, or those exponents. That's going to be 3 plus negative 7. So simplifying this and putting it all together, we're going to have our coefficient of 20 in front. And then moving on to our x's here, our x's are going to be combined, right? And let's go ahead and add their exponents. So we have a negative 5 plus negative 2. That's going to bring us an exponent of negative 7. Finally, for the y's, let's write that y here, and then adding this 3 plus negative 7, that's going to be negative 4. So that's raised to the negative fourth power. So the base is going to be y here, and the exponent is negative 4. So putting this all together, this 4 times 5 got us the 20 in our simplified expression. Then for x to the negative fifth times x to the negative second, we go ahead and add their exponents. So negative 5 plus negative 2, if we add those together, we do get this negative 7. And then finally, this y to the third power times y to the negative seventh power, we can go ahead and take their little exponents of 3 and negative 7, add them together. 3 plus negative 7 is negative 4. Here's 13. For 13, we have negative 3 times x to the seventh power times y to the third power times 5 times x to the negative third power times y to the third power. Starting with the coefficients, we have negative 3 multiplied by 5. So 3 times 5 is 15, so negative 3 times 5 should be negative 15. So that's going to be our coefficient out in front. Moving on to the x's, we have x to the seventh power times x to the negative third power. So let's go ahead and write this x next to here. And going ahead and adding these exponents, we're going to have 7 plus this negative 3. Finally, moving on to the y's, we have y to the third power times y to the third power again. So let's go ahead and write it using just one base instead of 2. And then let's combine the exponents to write 3 plus 3. All right, so simplifying this a bit, we're still going to have this negative 15 as our coefficient. And then for the x, let's go ahead and write our x as our base here, and then adding the 7 plus negative 3, that's really just 7 minus 3, so that's going to be raised to the fourth power. And then finally we have this y, and that's going to be raised to the 3 plus 3 power, but 3 plus 3 is 6, so we can say this is going to be y to the sixth power. So recapping, this negative 3 times 5 got us a negative 15 over here. X to the seventh power times x to the negative third power. We go ahead and add those exponents together to get x to the fourth power. We can see here that that's 7 and that negative 3. 7 plus negative 3 gets us that 4. And then when we multiply y to the third power times y to the third power, look at their little exponents of 3 and 3. We have 3 plus 3, and that got us our 6. For number 14, we have negative 6x to the negative seventh power y multiplied by 3x to the negative first power y to the fourth power. Let's start by multiplying the coefficients together. So we have this negative 6 multiplied by positive 3. 6 times 3 is 18, so negative 6 times 3 is going to be negative 18. So that's going to be the coefficient. Then multiplying this x to the negative seventh power times x to the negative first power, we're going to have this common base of x, of course, but then we're going to have this negative 7 plus negative 1. Moving on to the y's, we have a y over here, and that's actually raised to the first power, so we'll go ahead and write that 1 in if it helps. And then we have this y to the fourth power. So let's go ahead and combine this. We're going to have a base of y, and let's go ahead and add their exponents of 1 plus 4. Putting this all together, we're going to have negative 18 as our coefficient out in front. And then for our x's, let's go ahead and see what that's going to be. For our x's, we're going to have our base of x, and then let's go ahead and add their exponents together here. So negative 7 plus negative 1 is going to be negative 8. That's going to be the exponent right over here. And then moving on to our y's, we're going to have a base of y, and then let's go ahead and add those exponents. For the y's, it looks like we have 1 plus 4, and that's going to be 5. So putting this all together, we have negative 6 times 3, that's negative 18. Then for x to the negative 7 times x to the negative 1, we can go ahead and add that negative 7 and negative 1 together. Adding them, we get this negative 8. And then multiplying this y to the 1 times y to the 4, we go ahead and add that little 1 and little 4 together. 1 plus 4, that gets us this exponent of 5. For number 15, we have 9x to the fourth power times y to the negative seventh power times 2 times x to the negative fourth power times y to the second power. Let's start with our coefficients. So we have 9 and 2. 9 times 2 is going to be 18, so let's go ahead and put that out in front first. Then we can multiply this x to the fourth power times x to the negative fourth power, so we can combine those with the same base of x. But then when we do that, we can add their exponents of 4 plus negative 4. After that, we're going to take care of these y's. So we have y to the negative seventh power times y to the second power. So we're going to have this y over here, and that's going to be raised to the what? The negative 7 power plus 2. Putting this all together, we'll have this 18 as a coefficient out in front. Then we're going to have this x as our base, and let's go ahead and add these two powers together here. So it looks like we have 4 plus -4, and that's going to equal 0. And then for our y's, we have our base of y here, and let's go ahead and add those exponents. We have this -7 plus 2, and that's going to equal -5. Now try to remember that anything raised to the 0th power is just equal to 1, so this becomes 18 multiplied by 1 times y to the -5th power. And since 18 times 1 is just 18, we can write 18y to the -5th power. Finally, for number 16, we have 4x to the -5th power times y to the 3rd power times 8x to the 2nd power times y to the -3rd power. Start by multiplying the coefficients of 4 and 8 together. 4 times 8, that's going to equal 32. So let's go ahead and put that in front. Then we'll multiply x to the -5th power times x to the 2nd power. So let's go ahead and put this x over here, and let's add their exponents. We can add this -5 plus 2. And then moving on to the y's, we have y to the 3rd power times y to the -3rd power. So combining that, we have a base of y. And adding their exponents together, we're going to have 3 plus -3. Simplifying this a bit, let's go ahead and take our coefficient of 32. And then for x, we're going to have our base of x here. Then let's go ahead and add those exponents together. So -5 plus 2, that's going to be -3. And then for y, we have our base of y, of course. Let's go ahead and add this 3 plus -3, and that's going to equal 0. Now remember, just like in the last problem, anything to the 0th power is equal to 1. So this y to the 0th power can be replaced with 1 as well. So rewriting this, we can write 32 multiplied by this x to the -3rd power, multiply that by 1 because y to the 0th power is equal to 1. And then if we go ahead and multiply 32 times 1, that's just going to be 32. Then we're going to have x to the -3rd power. So that would be our final expression. And then finally, just recapping what the exponents did in 15 and 16. In 15, we had this 4 and this -4, the exponents for the x as the base. We can add 4 plus -4, that's 0, which is why that went away, turned into 1 because x to the 0th power is 1. And then for the y's, we had this y to the -7th power times y to the 2nd power. So -7 plus 2 is -5. So this -5 carried through the rest of the problem. In number 16, we had x to the -5 times x to the 2. And so -5 plus 2 is -3. So that carried through all the way. And then for a y to the 3rd power times y to the -3rd power, those are opposites. So 3 plus -3 must be 0, and y to the 0th power is just equal to 1. So that's why there's no y in our simplified expression. So there you have 16 different practice problems on dealing with these exponent properties or exponent rules, dealing with just products or everything was being multiplied together in these types of problems. If you found this video helpful, please consider giving it a thumbs up and maybe even sharing with a friend or classmate that may find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.